Hi, welcome to Namis Academy. This time we'll be talking about areal of segments. Recall that a segment is a part of circle when a circle is divided into unequal parts by a chord. Remember what a chord is? A chord is that line that does not pass through the center of the circle but divide a circle into two, therefore unequal parts, which is the opposite of diameter. Diameter is a line that divides a circle into two equal parts, but chord is a line that divides a circle into two unequal parts. So from the previous video, if you've watched, it tells that when a chord divides a circle into two unequal parts, we have segments, whereby the bigger part is the major segment while the smaller part is the minor segment. So let us look into this diagram we are seeing on our whiteboard. Can you see the diagram? It looks like can you see the diagram? You can see this part, this is the chord from A to B. The line AB is the chord. It has divided the circle into two equal parts, this place being the smaller part and this entire bigger part to be the major segment. So we have the minor segment, we have the major segment. So how do I calculate the area of this segment, including the major segment and the minor segment? So let's get into it. Let's take example number 1. Example 1. Find the area of the segment which so let's take example number 1. It says find the area of the Roman figure 1 minor segment, Roman figure 2 major segment of the diagram by the left. Now this is the diagram, we can see it. Now the first thing I told you is to introduce formula. What is the formula to calculate area of segments? That's alright. Area of segment, if you look at this diagram carefully, you will see that we have a sector having the segment in it, meaning that if we could find the area of the sector and subtract this triangular part away, then we have the area of the segment, and that is just the formula. So introducing the formula to calculate area of segment, I'm telling you that area of segment is equal to area of sector minus area of triangle. So you can remember from the previous video that area of sector is theta all over 360 multiplied by pi r squared, and you can remember that area of triangle is 1 all over 2 open bracket the base times height of the triangle. But in this case, the base and the height of the triangle are the radii. I mean, the base is the radius and the height is also the radius. Therefore, the formula becomes theta all over 360 multiplied by pi r squared minus 1 all over 2 r squared sine theta. So this is the formula to calculate the area of a segment. Calculate sector and subtracting the triangular part from it, then we have the area of the segment. So let's take on So let's take on the example given to us. So given that the value of theta is 60 for the minor segment, so let's give the parameters for minor segment. So for minor segment, we could see that theta is 60 degree, r is 21 centimeter. I think that is all we need to calculate this. So let us move into the next page to calculate the area of the minor segment. So putting those value into the parameters, so we have 60 over 360 multiplied by 22 over 7 multiplied by 21 multiplied by 21 minus 1 all over 2 multiplied by 21 over 1 multiplied by 21 over 1 multiplied by sine 60. So this is just it. So everything here is 1 over 6, right? Yes, 1 over 6 multiplied by 22 over 1 multiplied by 3 over 1 multiplied by 21 over 1. I believe you understood what I did here. 7 here 1, 7 here 3. So we are left with 22 over 1 and 3 over 1 here, 21 over 6. So minus, I can say this to be minus, I can say this to be 441 divided by 2 multiplied by sine 60, right? So I can still say 3 here 2, 3 here 1, 2 here 1, and 2 here 11. So I'm left with 11 times 21 at this side. 11 multiplied by 21 minus, if you divide this, 44 divided by 441 divided by 2. You know 440 divided by 2 is 2 by 2 is 0. 1 divided by 2 is 0.5. So that is 220.5 multiplied by sine 60 is 0.866. So So 11 multiplied by 21 is 231 minus 220.05 multiplied by 0.866. So we have 190.953. So simple subtraction. Subtract 190 from 200, will be left with 10. So that means we are going to have 41.0 So 231 minus 190.953 will have 40.047. Yes, 40.047 centimeter squared. So that is the area of the minor segment. So can we calculate for the major segment too? Roman figure 2. For the major segment, now our theta should be what? 300. That is correct. So theta should be 300, so that our R still remains as 21 centimeter. So putting it into the value of our formula, having known that formula is theta all over 360 multiplied by pi r squared minus 1 all over 2 multiplied by r squared multiplied by sine theta. So we can simply say 300 all over 360 multiplied by 22 over 7 multiplied by 21 multiplied by 21 over 1, so minus 1 all over 2, so multiplied by 21 over 1 multiplied by 21 over 1 multiplied by sine 300. So this 0 cancels 0, 6 here 5 and 6 here 6, so I'm left with 5 over 6 multiplied by 22 over 1 multiplied by 3 over 1 multiplied by 21 over 1 minus 441 all over 2 multiplied by sine 300. So 3 here 2, 3 here 1, and 2 here 1, 2 here 11. So I'm left with 5 times 11, which is 55, multiplied by 21. So 55 over 1 multiplied by 21 over 1 minus 441 divided by 2 multiplied by sine 300 is minus 0.866. So 55 multiplied by 21 So 55 multiplied by 21, we have 1155 minus, this is 220.5, 225.5, so multiplied by minus 0.866. So I have 115 minus, so 220.05 multiplied by 0.866. So that is minus 190.953. So I have minus multiply minus, it becomes plus. So that is 1155 plus 190.953. So my final answer will be 1345.953 centimeter squared. So this is the area of the major segment. I believe you understood what we did in this video. If you have any question, drop your comments. Bye bye. See you in the next video.